Hi kids, I hope you're all doing well. I miss you lots. It sure isn't fun just sitting at home without your humor, and I just miss you guys. And I'm going to try to do some practice problems for you. This is a new thing I'm trying out some YouTube videos to do practice with you. So we'll see how it works. But for today, what I want to do is just a few problems on the practice page. Yesterday you looked at the video that was from Flip Math and copied down their examples. So I wanted to give you, like we normally do, some practice problems together so that you would have an idea how to do the others. So I'm looking at numbers 1, 2, and 3, and I'm guessing that you would pick number 3 because it's got a trig function. Go figure, right? So they're looking for you to find the average value. It's really important that you watch the words that they use, because average value is different than an average rate of change, which we've talked about before. So average value is this new formula that they gave you, and the average value, I'll put it up here at the top. You need to see me. Hold on. Let me move it down a little. Average value, when they say that, they mean 1 over b minus a times the integral from a to b of some function with respect to x. So average value is now this formula, and again, it's very different from an average rate of change, which we're going to look at in a couple minutes. All right, so they want you to find the average value, and they give you the interval from 0 to pi. So you're going to set it up. You got a b of pi, you've got an a of 0. And you're going to set it up just like the formula says. You're going to do 1 over pi minus 0, b minus a, times the integral from a to b, 0 to pi, of the function sine of x with respect to x. And so you do the subtraction, you get 1 over pi. You take the integral, which is the antiderivative. So if you're doing an antiderivative of sine, it's negative cosine. And you're going to evaluate that from 0 to pi. So what does that look like? You've got 1 over pi, this outside coefficient. And if I put a pi into this place and a 0 into this place and do f of b minus f of a, that's where I'm heading next. So it's going to be a negative cosine of pi minus a negative cosine of 0, but negative makes this plus, a cosine of 0. So I have to go to my unit circle. Oh no, unit circle. All right, here's my unit circle. If I'm at pi, this coordinate's negative 1, 0, and if I'm at 0, my coordinate is 1, 0. Cosine's the x value, and so I'm going to f of b minus f of a, this whole hot mess. So if I do that, I've got 1 over pi. The cosine of pi is negative 1, but it's a negative 1, so it's really a positive 1. And the cosine of 0 is just a 1. So I've got 1 plus 1. Oh, look at that. 1 plus 1 is 2. And so I get a final answer that is 2 over pi. So there is number 3, asking you for an average value. And if I go to the numbers of 4, 5, and 6, and if I were to ask you in class which one you want me to do, you would pick 6 because it's got an e in it. All right, so let's try number 6. It's the same question. I'm going to do an average value. 1 over b minus a times the integral from a to b of f of x. So here it goes. 1 over b minus a, 1 minus a negative 3, times the integral going from a to b, going from negative 3 to 1, of the function 2e to the x with respect to x. So if I look at this, this is 1 plus 3, that's 1/4. And then I have, actually I can pull this 2 out, right? Can I make this the 2 the constant and the integral negative 3 to 1 of e to the x dx? So I just kind of make it a little simpler. 2 over 4 is 1/2. The integral from negative 3 to 1 of e to the x. And I really like the e to the x function because its integral and derivative are the same thing. So if I take the antiderivative of that, it's still e to the x. I've got 1/2 e to the x going from negative 3 to 1. And so all I need to do then is plug that in. So f of b minus f of a, it's going to be a 1/2 on the front. If I plug a 1 in, it'll be e to the first. If I plug a negative 3 in, it'll be e to the negative 3. And so if I distribute this, e to the first is just e. E times 1/2 is e over 2, 1/2 e. And if I do 1/2 times e to the negative 3, negative exponents means that e goes to the bottom in the denominator. So it would be 1/2 times 1 over e cubed. So that would be minus 1 over 2 e cubed, or some form of that. And that's your answer for number 6. Now the directions change for the next set. In the next set, they're saying on the given interval, find the x value where the function is equivalent to the average value. So you need to do the same thing. You need to find the average value, but then what you're going to do is figure out what the x value is where it would equal that average value. I'll show you what they mean. Looking at these 3 problems, probably the hardest one might be this one at the end, number 9. So job number 1 is let's find the average value. And so just like we did with the problems up above, we're going to take this thing and we're going to do 1 over negative 2 minus a negative 5 times the integral going from negative 5 to negative 2 of 2x squared plus 16x plus 28 with respect to x. Or, if I simplify that a bit, a negative 5 makes it positive 5, and positive 5 minus 2 is a 3, so 1/3. 1/3 the integral from negative 5 to negative 2 of 2x squared plus 16x plus 28 with respect to x. Now I need to know what that value is, what that's actually going to equal. So I'm going to actually use my calculator to do that for this one. And so in my calculator, let me see if I can find it so that you can see it better. In my calculator, if you turn it on and go to the home menu, I actually tried it just a minute ago. There it is. But I'll put it in for you. If I clear this out and try again, let me do this clear. All right, so I'm going to F3 calculate, and I want to know what the integral is. And so I'm going to number 2, and I want to know the integral of my function. Now my function is 2x squared plus 16x plus 28. And you know how this works with the calculator. Then you need to do comma x, comma, and you need to put in your lower bound and your upper bound. And my lower bound is negative 5. And my upper bound, my upper bound is negative 2. There, quickly it tells me it's negative 6. So, I know that this part's negative 6, but it's really 1/3 times negative 6. Don't forget the value in front, right? So I end up with an answer that equals a negative 2. All right, so on the given interval, find the x value where the function is equal to the average value. Well, the average value is negative 2. And you need to take the function was 2x squared plus 16x plus 28. You need to set it equal to the average value of negative 2. And then solve it out. Now, hopefully it'll factor, right? So you're going to bring the negative 2 to the other side. That gives you a 30. 2x squared plus 16x plus 30 is 0. Everybody's divisible by 2, so I can factor out a 2. X squared plus 8x plus 15. And then, lucky for us, factors of 15 that add up to be 8 are 3 and 5. So here I am, x plus 3, x plus 5 equals 0. 2 equals 0, I don't care, doesn't equal that. X equals a negative 3, x equals a negative 5, and you just found the x values where the function equals the average value. So your answers are x equals negative 3, x equals negative 5. All right, now the last one I want to do with you today is these problems from 10 to 12. Now looking at these guys, my guess would be you would probably pick number 12 because number 12 has an ln in it. So this one says find the average rate of change. Whoa, average rate of change. That is no longer the average value. Totally different. So for this one, I'm going to do an average rate of change. That's something you learned months and months ago. So average rate of change is like the slope. An average rate of change is like f of b minus f of a over b minus a. Totally a slope formula. So watch the wording. It's very important, and they're going to switch back and forth when you get to this section. All right, so if I f of b it minus f of a it, totally slope it out, this one's going to be, if I put an e in for this thing, it's going to be the ln of the square root of e minus the ln of the square root of 1, f of b minus f of a, over b minus a, e minus 1. All right, so what on earth is that going to look like? It would be like me saying the ln of e to the 1/2 power. Remember, square roots are 1/2. Square root of 1 is 1, minus the ln of 1 over e minus 1. Well, some things from ln's you probably haven't seen for a while. If I look at this, you've got powers can come down in front, so this would be like 1/2 the ln of e. And the ln of 1, if you remember that, is actually 0. You can check it in your calculator, but that's what it is, over e minus 1. And the ln of e, if you remember that guy, he equals 1. So you end up with this. You end up with 1/2 minus 0 over e minus 1. Crazy fraction work here, but that actually means that you've got 1/2 and you've got the e minus 1 in the denominator. So 1 over e minus 1 gives you ultimately 1 over 2e minus 2, and that is your answer for number 12. And so from this, what I want you to do is complete numbers 1 through 11, the ones we didn't do, and tomorrow I'll post some examples for the next set. So for now, your job is to complete numbers 1 through 11. You can email me with any questions, and I miss you guys, and I hope you're all doing well, and keep in touch. Bye.